Very good evening to one and all. Welcome back to our channel. Dear students, today I am going to explain about consolidation of soil. Previously we have seen about compaction of soil or soil compaction. So which is comes under unit 3 and consolidation of soil comes under unit 4 geotechnical engineering. Now coming to the what is consolidation of soil? The consolidation of soil is nothing but a compression of saturated soil under steady static pressure is termed as consolidation, which is completely due to expulsion of water from the soil voids. Consolidation is generally related to fine grained soils such as silt and clay, whereas compaction of soil we have seen coarse grained soil, that is gravel and sand. Coming to the consolidation which is comes under totally or purely fine grained soils. So how can we consolidate or how can we remove the or expels the water from the fine grained soil, we can see in this video. The process of consolidation is often confused with the process of compaction. So whereas compaction increases the density of unsaturated soil, here the consolidated soil, which is purely saturated soil, which is a time related process and increasing the density of saturated soil by draining some of the water from the voids of the soil. Then we are observing here the diagram about the compaction, how the soil grains will be set by the application of the load or compacting of the soil. So the second diagram we are seeing organic soil or particles which are set by each and every particle, and also we can see the particle compressive strength and particle matrix formation and particle consolidation process we are observing in the diagram. Then coming to the compaction versus consolidation of the soil. So here the compaction means totally we are going to be removing the air voids, and whereas consolidation of the soil, we are going to be reducing the water content present in the soil mass. So it is basically totally which is based on settlement of the soil or setting of the soil. Then terms and definitions we are seeing here. The first one is settlement. Settlement is nothing but a total vertical deformation at the soil surface resulting from the load. And coming to the consolidation, rate of decrease in volume of the with respect to time. And what is meant by compressibility? Compressibility is nothing but a volume change flexibility. So volume decreases due to unit load. And what is meant by contraction? Contraction is based on thermal expansion or temperature expansion. Change in volume of the soil due to change in temperature. So here what is meant by swelling and shrinkage? Swelling is nothing but a volume expansion of the soil. Shrinkage is nothing but a volume contraction of the soil. Then coming to the what is meant by initial or immediate elastic settlement. So here the word is called as the initial or immediate or elastic settlement. That is load when we applied on the soil, particular soil or partially saturated soil, a decrease in volume occurs due to expansion or compression of the air in the air voids. A small decrease in volume occurs due to compression of the soil particles. The reduction in volume of the soil just after the application of the load is known as initial or immediate or elastic deformation or settlement or compression. For saturated soils, the initial consolidation is mainly due to compression of the soil or solid particles. Then coming to the different types of the soils, how it will be set or how it will be occurs or going to deformation or settling. When we come to the clay soil constant modulus of elasticity which is having with the depth, and lateral conformation or confinement pressure will be exist. So when we apply the load a small deformation will be occurs in the soil mass. And sandy soil also increasing modulus of elasticity with the depth, and which is having lateral confined pressure does not exist. So the diagram will show about the initial or immediate settlement of the soil. And coming to the second part, or second type of the consolidation, that is primary consolidation. After the initial consolidation, further reduction of the volume occur due to expulsion or expulsion of the water from the voids. So previously we have seen the immediate settlement, which is not expulsion of the water, or which is not going to expulsion of the water, but which is removing of air voids, or air gaps we are going to be removing by applying static load. Whereas here primary consolidation, which is having initial expulsion of the water will be takes place here. The reduction of the volume occur due to expulsion of the water. When a saturated soil is subjected to pressure, initially all applied pressure is taken up by the water as an excess pore water pressure. Whereas here the hydraulic gradient would develop and the water starts flowing out, and a decrease in volume will be occurs. The reduction in volume is called primary consolidation. In fine grained soil, primary consolidation occurs over a long time. However, coarse grained soil, which is occurs very short period. That is the difference of the fine grained and coarse grained soil. When we observe the diagram, saturated clay mass we are observing. While applying the load, the settlement is occurs very slowly, because initially the settlement is zero before application of the load, and the time is going or increasing the load, or the time is going to increasing, the settlement also will be increases along with the time increases. That is the primary consolidation will be takes place, because how it will be sets, or how it will be occurs the settlement while expulsion of the water from the soil mass, it will be takes place. Then the settlement will be occurs very slowly or very gradually. Secondary consolidation is also a reduction of the volume of soil mass, and it is also happens another expulsion of the water will be takes place. The additional reduction of water will be takes place while secondary consolidation is happening. So this is the difference of the primary consolidation, secondary consolidation, and initial compression or consolidation. So initially there is no expulsion of the water will be takes place. Very small amount of settlement will be occurs due to applying of the load. But the primary consolidation and secondary consolidation, some amount of water will be expulsion from the soil mass will be takes place. That is the difference of the initial, primary, and also secondary consolidation process. So here some key points will be noted. Initial compression or consolidation will be imperfect saturation, whereas elastic compression will be takes place, and a small quantity of air in the soil will be expelled. Primary consolidation will be expulsion of pore water for long period of the time will be takes place. More than 90% of the consolidation is due to primary consolidation will be occurs. Secondary consolidation, rearrangement of the particles will be takes place, as well as plastic deformation will be occurs, and viscous layers formed around soil particles. That is the three kinds of the compressions or consolidations will be takes place in the soil mass, that is saturated soil mass. The total settlement will be occurs, whereas initial compression, primary settlement, secondary settlement. So when we come to the numerical value, that is total settlement is equals to elastic settlement, which is denoted with S suffix E, and primary settlement, which is S suffix P, and also secondary settlement consolidation will be denoted with S suffix S. So these are the three different types of the settlements or consolidation process will be occurs in the saturated soil mass. So here we are observing the diagram or graphical representation of the three different settlement process we are observing. So whereas increasing of the time, there is a occurrence of the settlement will be takes place. So initially zero consolidation will be there, and the time is going on. The primary settlement will be 90%, whereas secondary settlement process or consolidation is 100% will be takes place in the graphical representation. Then coming to the difference between compaction and consolidation of the soil. So here some of the key points we need to note it down. The compaction will be based on dry density and optimum moisture content of the soil mass, whereas consolidation is based on saturated soil, which is based on settlement process, whereas expulsion of the water content will be happening here. The compaction is the compression of the soil mass with the expulsion of the air voids, whereas the consolidation is compression of the soil by expulsion of the water from the voids of the soil. And the compaction is a quick process, which is very shorter period will be takes place, and the consolidation process is very slower process. It will take more time for the settlement process will be occurs, or expulsion of the water will be takes place very slower process, because the consolidation which is happening in the fine grained soil just like clay and silt particles, which is having very less amount of void ratio, less permeability will be takes place. That is the way the expulsion of the water will be takes place a very longer period of the time. That is the consolidation process. Whereas short term loading is required for the compaction, whereas the long term loading is required for the consolidation. The loading is in dynamic way, loading is static and constant way in the consolidation. Any type of soil, either it is cohesion or cohesive soil, can be compacted, whereas the consolidation will be applied only in the cohesive soils, just like clay or silt particles of the soil. The degree of saturation of the soil to be compacted should be 100% here, and the degree of saturation of the soil to be consolidated should be 100%, whereas in the consolidation process. And the shear strength will be increases both the ways, with either in compaction or consolidation. The shear strength of the soil will be increases. Void ratio, compressibility and permeability will be decreases in the compaction, whereas in the consolidation also. The bearing capacity of the soil, settlement of the settlement characteristics of the soils will be improves in the both the ways. The compaction is done purposely to get the maximum dry density of the soil, whereas consolidation of the soil occur naturally due to structural loads from the foundations. It is done before the construction of the structure, whereas it will be begins naturally along with the construction of the work. To construction of the roads, earth dams, embankments, the compaction is more useful or applied. In the same as the foundation of the soil particles will be improves over the long period due to consolidation process. These are the few differences we'll be observing the compaction and consolidation process. With this introduction, I am going to explain about Terjage's theory of one-dimensional consolidation. A consolidation is the gradual process of reduction of the volume. Under the static loading, reduction in volume of the soil due to squeezing or expulsion of the water from the soil. And it is a process which occurs in natural when the saturated soil deposits are subjected to static loading caused by the weight of the building or any other structures. The theoretical concepts of the consolidation process will be studied by the Terjagis in the year of 1923. So, Seddagi theory, which is also very useful theory for the one-dimensional consolidation process. The assumptions are made by the Terjagis theory. The first one is soil is homogeneous and isotropic. What it means? The homogeneous means the soil is same kind of the material we are assuming, or Terjagi is assuming as the soil mass is same kind of the material. And isotropic means in the soil in all the directions the forces will be acting same. That is the meaning of isotropic. The soil is completely saturated soil. The soil grains and water are incompressible. The load is applied in the vertical direction only, and the drainage of the pore water is one dimensional way only. The primary consolidation is totally governed by the expulsion of the pore water, that is, at the initial stage, the pore water is 100%, the consolidation is 0%. Whereas the final ending condition, the pore water is 0%, the consolidation is 100%. That is the assumption made by the Terjagis. And the soil mass remains saturated after the primary consolidation also. The coefficient of permeability of the soil is constant because in all the directions the permeability is same, or properties of the soil are same. That is the isotropic condition of the soil. That is the way the coefficient of permeability of the soil is also constant. The coefficient of compressibility and the coefficient of volume change, which are also constant for a given type of the clay soil, because the Terjagi is studied or tested a clay mass very well for the one-dimensional theory of consolidation process. The time lag of the consolidation occurs mainly due to low permeability of the clays. The last one is Darcy's law is valid. These are the assumptions of the Terjagi's one-dimensional theory. Some of the equations will be made by the Terjagis, that is consider first of all he considered continuity equation and coefficient of the compressibility, coefficient of volume change in the development of the equation of the one-dimensional theory. The equation will be having like this: dou u suffix w divided by dou t is equals to k divided by mv into gamma w into dou square uw divided by dou z square, whereas uw is the pore water pressure, t is the time of primary consolidation, k is the coefficient of permeability, mv is the coefficient of volume change, and z is the effective drainage depth of water. This equation is made by the Terjagis, and one more equation, that is coefficient of consolidation, Cv is equals to k divided by mv into gamma w, and one more equation is time of consolidation, how much time it will be take for the consolidate of the soil mass, that is t suffix v is equals to c suffix v into t divided by d square. And coming to the one more equation, that is time factor, t suffix v time factor, which is two ways we are going to be taking, and one is tv is equals to pi by 4 u divided by 100 whole square, that is for the lesser than of the equal to 60%, and tv is equals to minus 0.9332 into log 1 minus u divided by 100, that is for the greater than 60% of the fine particles. Less than 60% of the fine particles is pi by 4 into u by 100 square, and more than 60% of the fine particles, tv is equals to 0.9332 into log 1 minus u by 100 minus 0.0851. So, whereas u is the degree of consolidation ST is the settlement of the any time. SF is the total primary settlement of the soil, and CV is the coefficient of consolidation. T is the time of primary consolidation, and D is the length of the drainage path of the water from the soil mass. Then, by this continuation, the Tejagi is noted some points. What are those points Tejagi is noted? In case of double drainage, the time of the consolidation gets reduction to 1 by 4th of the time required in case of single drainage of the water from the soil. So, if you take two types of the drainage paths. One is single drainage, double drainage. Single drainage, maximum pore water need to travel from the bottom to pervious layer or bottom to top, which is having capillary action. Bottom to top, the water will be travels. Whereas in the double drainage path, when we observe the double drainage path, either side of the path, the water will be expelled from the soil mass. That is the first point noted from the Tejagis. The total consolidation that remains the same in case of both single and double. This is very much important. So either you take single drainage path or double drainage path, the total consolidation will be same or remains same in case of both the cases. So finally, in case of 100% consolidation, so we'll be having become infinity, or eventually the time required for the consolidation T also becomes infinity. So when we get the 100% of consolidation, the time which is going on, so infinite time we are getting 100% of consolidation process, because the consolidation process means what? The pore water pressure definitely it will be comes down to the 0% of, that is the meaning of 100% of consolidation process. When it will be takes place, the settlement time will be having infinite time, it will be takes, and 100% of the consolidation will be takes place. Here some ratios we are observing, that is over consolidation ratio, the ratio between pre-consolidation pressure experienced in the past to the effective stress action at the present on the soil. So over consolidation ratio, which is denoted with OCR, that is sigma past to the sigma present. So this over consolidation ratio, when we understand about the pre-consolidation pressure, then only the over consolidation ratio will be understood. So based on the OCR, the soil, that is clay, are classified as, if the OCR is more than 1, it is over consolidated clays. OCR equal to 1, that is normal consolidation clay. If the OCR is less than 1, under consolidated clays. These are the three different kinds of the values which will be having: over consolidated clays, normal consolidated clays, under consolidated clays. OCR is more than 1, OCR is equals to 1, OCR less than 1. So that is the three different kinds of the differences we are observing here. Then coming to the where we apply the application of the consolidation. The application of the consolidation, which is the same as compaction process also. So when we observe the compaction applications, there also we are going to be applying for the earth retaining structures and settlement analysis process, ground improvement techniques, pavement design. So like that, the applications of the compaction, which are same as applications of the consolidation. The one different will be having, that is foundation design. When we go for the foundation design of any kind of structure, the consolidation process is very much important, because when the time is going on, the settlement of the structure will be takes place. So whenever the settlement of the structure will be takes place, the structure will be collapse, by the taking of the time. That is the way, by the going of the foundation design, the consolidation process is very much applicable for the designing of the foundation. Whereas earth retaining structures, like going on highway constructions or flyover constructions, the earth retaining structures will be takes place, and earthen dams will be also, earth retaining structures will be takes place, and settlement analysis and ground improvement techniques like preloading using vertical drains, leverage soil consolidation to enhance the soil strength and reduction of the settlement. The pavement design, road construction or airport runway construction also will be needed of the consolidation process, because the settlement of the road construction or pavement construction and airport runways also will be settled down into the soil. So that is the way the pavement design which will be also more applicable for the consolidation process. And dewatering projects, so dewatering projects means bridges, bridge constructions, dams will be comes under dewater projects, and land filling designs, tunneling process, seepage control, and finally geotechnical risk assessment. So these are the main applications of the consolidation process will be in the civil engineering point of view. And coming to the where we apply the knowledge of the consolidation process, some of the questions we are going to be discussing some of the theoretical or quiz questions about the topic. The first one is the theoretical concept of consolidation process was developed by, we know that is the theoretical concept of the consolidation process first developed by the Terjagi in the year of 1923. Already we have discussed in the first slide or second slide. And the Terjagi theory of one-dimensional consolidation, the soil is considered to be, here some of the options will be given like this: homogeneous, non-homogeneous, anisotropic, and heterogeneous. So the first assumption made by the Terjagi is homogeneous and isotropic. The soil is homogeneous and isotropic. With this knowledge, we conclude the consolidation process. This consolidation process is very much important in the public sector examinations or private sector examinations or private companies. The consolidation process is very important, because every construction or every structure is going on for the construction. The consolidation process is a very important topic, because every construction or every structure will be going through the foundation design. That foundation design must be having the knowledge about consolidation process. While going to designing about the foundation, the person or the engineer must be have the knowledge about the settlement of the soil properties. That is the main thing we have discussed about the consolidation process. So if you have any questions, you can post in the chat box, or you can freely ask in the classrooms. Thank you for listening the video.